Okay, so now we're going to start Appendix 7, which covers complex numbers. So what is a complex number? The definition of a complex number is any number in the form a plus bi, where a and b are real numbers. Okay, so for example, you could have a real number of 5 being added to a negative 2i. Because you have a real being added to a imaginary, it is complex. These numbers could also be irrational. So it could be, for example, the square root of 3 minus 8i. That would also be a complex number. Or it could be 4 plus I times the square root of 7. Okay, but the key is that these two numbers have to be real. They don't have to be positive necessarily, but they have to be real numbers. Okay, so let's do some operations with imaginary terms. If we go back to Algebra 2, we covered two things in Algebra 2. And those two things are that I is equal to the square root of negative 1 and that I squared is negative 1. Those were the only two rules. If you know that, you can solve or find the value of any I to any exponent because it is cyclical. Every 4 rotations, it starts over. So I cubed is actually equal to negative I. And how did I get negative I? So I got negative I by separating that I cubed down to an I squared times I. We already know that I squared is negative 1. And so negative 1 times I is equal to negative I. And then I to the 4th is positive 1. So the rotation goes I, negative 1, negative I, positive 1. Again, I, negative 1, negative I, positive 1. Anything with an exponent that is a factor of 4 is going to equal 1. Okay, so let's simplify a few more powers. So let's look at I-29. So because I know that the first thing I'm going to do is say, well, what's the highest factor of 4 that I can take out of 29? The highest factor of 4 is 28. So I'm going to take this apart and separate it to I-28 times I to the first. 28 plus 1 is 29. Because this is a factor of 4, I know that this is going to equal 1. And I also know that I to the first is I. So we have 1 times I, or I. That is the answer. That is what I to the 29 would simplify down to. All right, let's do the same thing with 67. So let's see, how many times does 4 go into 67? I don't know the highest factor. So this is what you would do. Bring down the 7. So 4 goes into 27 6 times. Okay, so because it goes in there 6 times, so 4 times 16 is 64. So if I break this down to I-64, I-3, again, this is a factor of 4, so that's going to be 1. And we already know that I to the power of 3 is equal to I squared times I, or negative I. So our answer is negative I. 42, that can be broken down to I-40 times I squared, which is 1 times I squared, which is negative 1. So our final answer is negative 1. And lastly, we have I-24, and 24 is a factor of 4. So I know simply that that is just going to equal positive 1. Okay, so when we simplify, we're going to combine our like terms. So for addition, all we need to do for addition is combine our like terms. So I'm going to start with the real numbers. That gives me 9. And then I'm going to add my imaginary numbers. And that's negative 2i. And that is it. For number 2, because it is subtraction, we will have to distribute that negative. Okay, so it becomes that, because we're distributing our negative. We combine our like terms. We have a negative 5, and we have 15i. For number 3, we're going to make our box. And we're going to just fill in our squares. This last column, this last square, we're going to have negative 20i squared. And I'm going to not write that in the box just yet because I squared equals negative 1. So what's really in that square is a positive 20. So when we combine our like terms, we have 20 minus 6, which is 14. And then we have negative 15i, negative 8i, which is negative 23i. Now, I recommend that you pause the recording to try to do number 4 on your own. So we're going to make our box here. And we're going to fill it in. Negative 12, 8i, negative 3i. And in this last column, you would have 2i squared, which is going to equal negative 2. Combine your like terms, and that gives you a negative 14 plus 5i.